Okay, so today we're starting section 1.7, and in 1.7 we're going to be talking about perpendicular lines, perpendicular bisectors, and an angle bisector. So we've got some new vocab terms. Perpendicular lines, you guys have studied these before, so what we're going to fill in for today is this is going to be two lines that intersect to form right angles. Okay, so two lines that intersect to form right angles. Those are perpendicular lines. There's a symbol that you're going to see used for perpendicular lines. And perpendicular lines, it looks kind of like an upside down T, but anytime you see this symbol, I want you to think perpendicular. Okay, if I look at this diagram over here, what I can see here is that I have these lines right here, AB, and line CD. They are perpendicular because I have this box right here. And remember, that box means that this is a 90-degree angle. Okay, if this angle is 90 degrees, then we know traveling from one side of the line to the other, or this straight angle measures 180, that would ensure that this also has to be 90 degrees. The one next to it is 90 degrees, and this one is. So these two lines are creating four right angles. I can say that line AB, using my notation, is perpendicular to line CD. Okay. The next vocab term that we're going to look at is a perpendicular bisector of a segment. Okay, so this is going to be a line, segment, or ray that intersects a segment. Oops. A line, segment, or ray that intersects a segment at its midpoint. So at its midpoint, and forms right angles. Okay, so this term right here is probably a new one, bisector. Bisector, what it means is it cuts the figure in half. It creates two equal segments, okay? So when we say that a perpendicular bisector is a line that's going to cut another segment at its midpoint and form right angles. So we have the perpendicular piece, the right angles. The bisector means passing through the midpoint will cut it in half. Okay, in this diagram right here, it says CD is a perpendicular bisector of segment AB. And I've said time and time again, as soon as we have information, you should mark it on your picture. So this line right here is bisecting segment AB. That means this was my midpoint, so these two segments are congruent, AO and OB. The other thing I know is that they are perpendicular to each other, so I can mark a 90-degree angle there, which would ensure these are all 490 degrees. Okay. The last new vocab term for today is an angle bisector. And an angle bisector, this is going to be a ray that divides an angle. A ray that divides an angle into two congruent angles. Okay, so that term bisector again means it cuts it in half. On our diagram, it says this ray, BD, is bisecting angle ABC. Okay, so this angle is getting cut in half by BD. We mark congruent angles just using little arcs on our diagram. Okay, we could say that BD is the bisector. Other things we could state is that ABD is now congruent to angle DBC. Okay, so moving into some example problems. This first one says, ray KN bisects angle JKL, and the measure of angle JKN is 5x minus 25. The measure of angle NKL is 3x plus 5. Solve for x, the measure of JKN, the measure of NKL, and the measure of angle JKL. Okay, so what I would tell you to do first is draw it. Sketch this angle, JKL. So go ahead and put an angle on your paper. We label it JKL. I have KN, ray KN is the bisector. That means it is cutting through this angle. And once again, I am going to mark that these angles are congruent right away. Okay, what they give me for information, JKN, so JKN is this top angle here, is going to measure 5x minus 25. NKL, this bottom angle right here, is going to be 3x plus 5. So I'm not using angle addition here, I'm using the idea that these two angles are the same. They are congruent, so really they're going to be equal to each other. Okay, I'm going to continue to solve from here, so get our x's to one side. I'm going to have 2x minus 25 is equal to 5. To bring this 25 over, we're going to add it. I'm going to end up with 2x equal to 30. And then from here, I need to divide by 2. And my x value is going to be 15. Okay? So like I've said several times, in geometry, we don't just stop at x. Then we go and we plug them in for whatever they're asking for. So they want the measure of angle JKN. I go back and substitute in my value. So JKN was 5x minus 25. I'm taking 5 times 15 minus 25. 5 times 15 is 75. 75 minus 25 would give me 50. Okay, the measure of angle NKL. Well, we know it should be the same as JKN, but let's check it. We take 3 times 15, which was our x value, and add 5 to it. 3 times 15 is 45. 45 plus 5 is 50. Looks like we did a good job. Okay, this last one says measure of angle JKL. Well, if this angle, JKL, is the whole thing, I know the first angle was 50, the second angle is 50. If I add 50 and 50, this angle is going to measure 100 degrees. And then I like it if you guys put boxes around your answers so they're easy to find. Okay, on the next diagram, you could give this one a try if you want to pause it. Okay, similar to the last one. WR bisects AWB. Okay, so let's draw in that picture. There's my angle AWB. WR is the bisector. So what do I mark on it? Congruent angles. Okay. AWR, so angle AWR is measuring x. Angle BWR, so BWR, this angle down here, is 4x minus 48. Okay. So think about it. What would you do to solve? Set them equal. Okay. And from here, I would subtract my 4x. And I would get negative 3x equal to a negative 48. My last step would be to divide by negative 3. And I find x is equal to 16. And I think, okay, did I answer the question? No, they want the measure of angle AWB. AWB is going to be the full angle measure, okay? So if I substitute in 16, this angle right here is 16, okay? If I substitute in 16 here, 4 times 16 is 64. 64 minus 48 leaves me with 16. So the measure of angle AWB would be 16 plus 16, which is 32 degrees. Okay, so those two both use my term angle bisector. This last one is going to use that term perpendicular bisector. It says segment WZ is the perpendicular bisector of segment AB. Okay, so what they're saying is this line right here is the perpendicular bisector. As it slices through, it hits the midpoint, so these two segments are congruent. You need to mark that. The other piece is the perpendicular. So perpendicular means it's going to form a 90-degree angle right here. Okay? What they're asking us to find is X, AC, and CB. Well, they want us to find segments. Okay? So these segments, if this point is the midpoint, remember these two have the same length. They are equal to each other. I'm going to say 6x plus 3 is equal to 2x plus 15. If I subtract the 2x, what am I left with? Well, I have 4x plus 3 is equal to 15. On my next step, I would subtract the 3. And now I have 4x is equal to 12. Dividing by 4 would leave me an x value of 3. Okay, the next piece we need is AC. Well, we're going to substitute in. We're going to take 6 times, our x value is 3, plus 3. Well, 6 times 3 is 18, and 18 plus 3 is going to be 21. Okay, the last one, CB. Well, we already know these two should be the same, but we should still check it. So we're going to go 2 times x, which is 3, plus 15, 2 times 3 is 6. 6 plus 15 gives me 21. So it looks like we're good. Okay, after you finish your notes, show them to Miss Terpstra so you can get your worksheet for today.